Good morning. All right, last day until spring break, so we are almost there. I'm going to go through some review questions. I know people didn't specifically ask, but I'm not necessarily going to post the answer key like I usually do for the review, but I will do a good majority of these. So you can kind of skip forward if you are good with that question or just want to check it. You are welcome to kind of go at any point in time. So just a couple things. I put it in the comments, but number 2 should have f of x is equal to x squared plus 1, and in number 4 it should be negative x squared minus 1. So make sure you add those two things. Our directions for the first page say sketch the parent function, and then graph each of the functions, and then we want to compare. So we know that our parent function is, we can say g of x, or we can say y, we could say f of x. I can't say f of x if I'm putting it into Desmos, because I can't have both of those be that. So it's x squared, and we got pretty good at graphing this. If I plug in 0 for that, I get out 0, so 0, 0 is part of our parent function. If I plug in 1, 1 squared is 1, so 1, 1 is part of our parent function. If I plug in negative 1 squared is positive 1, so we get negative 1, 1, and then if I plug in 2, 2 squared is 4, so 2, 4 is a point for our parent function, and then we also have negative 2, 4. So this right here is our parent function, so we should have that graphed on all of these on the first page, because in the directions it specifically says to graph the parent function. So then if I were to use Desmos, we could go ahead and type in, if you want to type in your parent function on Desmos, that's perfectly fine as well, but you don't necessarily need to if you understand that and you're good to go. So we can type in f of x, or I'm just going to put y equals, just because that's easier than on my phone, the app, instead of using the keyboard and typing in f of x. So y equals x squared plus 1. So again, we know we can click on that vertex, so that x value is going to be the middle of our table. So if we click on the gear like we have been doing, I can convert it to a table. So if I click that, 0 is already that middle because I haven't shifted it left or right. So my table values are going to be these numbers, so negative 2, 5, negative 1, 2, 0, 1, 1, 2, and 2, 5. And we should have that symmetry if my vertex is in the middle, so 2 and 2, 5 and 5, so I can go ahead and graph those points. And if I were to do that, our new function would be negative 2, 5. We have negative 1, 2. We have 0, 1. And we also have 1, 2. And the last point that we have is going to be 2, 5. So we can go ahead and graph that. So the only thing that changed from our parent function to this is that plus 1. So we know that that plus 1 is going to result in a vertical shift up 1. I didn't do a stretch or a shrink or anything like that, so we just end up with vertical shift up 1. So that is number 2. So number 3, again, our parent function, we can't graph everything, but I can graph 1, 1, negative 1, 1, 2, 4. I can't, so I'll just leave that as that. So then we need to figure out what's different. Well, this negative sign is different, so I know that negative is going to mean that it opens down, or it's going to reflect across the x-axis. And then that 1/2, if I look at the rules in our notes, that is going to be a vertical shrink by 1/2. So it's smashing it down, so it should get wider as we go for this. So again, I can use Desmos. So if I go ahead and clear out the previous one, I can type in y equals. So y equals negative, and then 1/2, and then we have x squared. So again, if I click on our vertex, I can see that 0 is my x value. So when I go to make our table, I'm going to make sure 0 is in the middle, and that's what it always defaults to, which is really nice. So these are the values of our table. So negative 2, negative 2, negative 1, negative 0.5, and so on and so on. So these are what I'm going to graph on my graph down below. So if I were to graph those, we have 0, 0. We have negative 2, negative 2. We have negative 1 and negative 0.5. We have 1 and negative 0.5, and we have 2, negative 2. So again, if I, oops, I thought that was blue. So if I look, it definitely got wider, which means that we shrunk it vertically and made it wider there. Okay, so there's number 3. Last one on the first page that I'm going to look at, and then we'll keep on going. So we have negative 3x squared So parent function, again, we know is x squared. So we have 0, 0. I can also graph 1, 1 and negative 1, 1, but I don't have anything else that I can graph, so we'll just roll with that. So there's our parent function. I, again, have this negative. Anytime we have a negative, we know that that means it's going to open down. And then that 3 is going to be, if we look at our notes, a vertical stretch by 3. So if it's a vertical stretch, we should be getting a skinnier parabola. So again, if we type that into Desmos, super nice that we have this to be able to use. So we have y equals negative 3x squared. And if we click, our vertex again is that 0, 0, 0. So super nice. It defaults to that in our table. So these are the values that I need to use. Negative 2, 12. Or sorry, negative 2, negative 12, negative 1, negative 3, 0, 0, 1, negative 3, and 2, negative 12. Again, if I put that vertex in the middle, we should have that symmetry piece there for us to be able to graph those. So now if I were to graph that, I still have 0, 0. I have negative 1, negative 3. We have 1, negative 3, and then negative 2, negative 12. And we have 2, 12, and make sure when we're graphing that parabola, it does go through each of those points. And it should look something like that. So again, the directions on the front only said to graph the parent, graph the new, and compare. So the negative opens down, the vertical stretch of 3, and make sure you have all of those points on your parabola. Okay, so there's the first page. Again, you are welcome to kind of skip ahead if there's certain ones. I'm not going to do all of them, but I have a good amount that I'm going to do. So we're going to look at 7 and 9 on this page. So we got to make sure we answer all these. It says sketch the graph of each function. We need to name the vertex. We need the axis of symmetry. We need to determine is it a max or min, the domain and range, and then we want to draw in the axis of symmetry. And we're also going to determine when it's increasing or decreasing. So again, we are going to resort to using Desmos. So if I were to go ahead and type in, try to put it somewhere where there's not much of a glare from the light of the Elmo, I have y equals, and then we have negative x squared. So that negative should tell me it's going to open down, and then plus 4x. So again, I'm going to click on Desmos, and I need to figure out where that vertex is. So my x value is 2. So when I go to create a table using the gear, I need to make sure I rearrange 2 in that middle. So if I click on the gear, it defaults to 0, but I need to make sure that I switch this to 2, and then I'm going to have to change all the numbers around. So 2. It doesn't really matter, I guess, which way you go, but I'll stay consistent going bigger. So I need to switch this to 3, 4, and then it gives me those values, and then below 2, I need to switch over to 1. If I don't do this, I'm not going to get that symmetry effect. So we got to make sure we do this, and then I have 0. So now 2, 4, and then I have 3 and 3. I have 0 and 0. So those are the points that I'm going to go ahead and graph on our graph over here. So if I go ahead and do that, we have 0, 0. We have 1, 3. We have 2, 4. We have 3, 3, and we have 4, 0. So we can go ahead and graph our parabola. We've got our 5 points to be able to do so. So it's kind of not a very good looking parabola, but it is what it is. Okay, so now we need to make sure we answer all the other questions. So we sketched the graph. We need to name the vertex, so probably a good idea to label these things. So just like you did on your quiz that you took last week. So our vertex is 2, 4, and we can use that on Desmos to find it, or we can look on our graphs. That's our vertex. We need to say the axis of symmetry, and it says to draw it in there, so that's important. And we have to make sure we're not just saying a point. An axis of symmetry is a line, so I need to have the equation of this vertical line that goes through our vertex. So we know that we can use Vux for a vertical line. So our equation is going to be x equals something, and in this case it's 2. So x equals 2 is our axis of symmetry, so we've taken care of that. So if I look, our vertex is at the very highest. So it's not whether it opens up or down, it's at the highest point necessarily. So just because it opens down doesn't mean we have a min, it's actually the opposite. Our vertex is, again, the highest, so my maximum is going to be my y value of that. So it is going to be a maximum, and it is going to be a maximum value of 4. So now we've stated the max and min, so now we need domain and range. So my domain is going to be all reals, right? It keeps going to the left, keeps going to the right. And then our range, we know our y values, and it's everything that is below 4. And 4 is included because there's a point there. So everything below 4 we can say is y is less than or equal to 4. So we have that. So then the last thing we need to state is when it's increasing and decreasing. So if I look, my graph is increasing on this side of x equals 2, and then it's decreasing on this side. So we can say it is increasing when x is less than 2. We can't say equal to because that's where it stopped, right? If it's increasing and decreasing, it has to stop somewhere. And then we can say it is decreasing when it gets to the other side. So when x is greater than 2. And overall, we did a pretty good job with this kind of problem on the quiz from last week, which is great. Okay, so then the last one on the second page, we have number 9 that we're going to look at. So again, we can use Desmos. So if I go ahead and plug that in, we have y equals 2x squared. This one's not going to open down because there's no negative out in front of that. So minus 16x. And then we have plus 34. So again, using Desmos always gives us the vertex. So my vertex is 4, 2. I could go ahead and write that if I wanted to. Also should be able to figure out my axis of symmetry goes right through there. So it would be x equals 4. But we want to go ahead and make the table to get some more points. So since our vertex was 4, 2, we need to make sure that my middle number in my table is going to have our x value of 4. So we have 4, and then I can change this to 5 and 6. And then this way it needs to go the opposite. So I can go 3, and I can go positive 2. So now we have those values in Desmos that we are able to use in our table, and we have that symmetry. So 4 and 4, 10 and 10, which we're good to go. So we can go ahead and graph those. So 4, 2, 5, 4, 3, 4, and 6, 10. And we also have 2, 10. So we know we have to draw in our axis of symmetry, so we could go ahead and do that. So typically we draw it as a dashed line, and then we need all of those things. So our vertex here is going to be 4, 2. My axis of symmetry is going to be, again, it's a line, it's a vertical line, which we can use Vux, so x equals 4. So x equals 4, so we have that. We also need to determine if this is a max or a min, so my vertex is at the very bottom of the rest of my points, so that's going to be a minimum. And the minimum is at whatever our y value is there, so it's going to be at 2. So we have that. We need to state domain and range, so our domain's always all reals, and then our range, we need to think about our y values. So it goes down to positive 2, and it's everything above positive 2, and it can be that, so y is greater than or equal to 2, and then we need to state when it is positive or when it's increasing and decreasing. So it starts out as decreasing, so we can say that it is decreasing when, in this case, our x value is less than 4. So when x is less than 4, and then it starts to increase on this side, so it is increasing when x is greater than 4. Okay, so we should have that for number 9. Okay, so that's the second page. So the third page, we got a few. So sketch the graph, and then state specific transformations that would have occurred from the parent graph. We don't have to graph the parent graph. This is in vertex form, so I should be able to look and know that my vertex is -2, -4. If you don't know that, then that's fine. You can put that into Desmos and you'll be able to see that. But we need to think about what these things do. So we'll go ahead and do that. Looking at our notes, this -4 out here in vertex form is going to be a vertical shift down 4. And then this +2 in here is actually opposite. This one goes left and right inside of our parentheses, but just like we did with exponential or we did with the linear functions, if it's a +2, it actually is going to go to the left. So this is going to be a horizontal shift left 2. And then we just need to be able to graph it. So I'm going to just type this into Desmos to be able to do that. So we have, I'm going to say y equals, and then in parentheses, x +2, and then squared, and then we have -4. So if we look just to double check those things, we said that it went left and down 4. What it's saying is our vertex. Our parent function is 0. I went left 2 and down 4, and that's where our new vertex is. And we can see it definitely is that -2, -4 that we said. So if I make a table, my middle value needs to be that -2. So I need to switch where 0 is, and it needs to become -2. And then Greater than that is -1, and then 0, and then the other side we have -3 and -4. So now we have those 5 points we can see on our graph that I'm able to use. So we have that table. So if I were to graph those, -4, 0, and we have -3, -3, we have -2, -4, we have -1, -3, and we have 0, 0. So we have those points that we are able to go ahead and graph our parabola. So our directions just said to graph and then state the specific transformation, so that's all we would have there. Only that x plus 2 and the -4 out there is going to change. All right, 14. We've definitely got some more things here. So if we go, this negative is going to make it open down. This 4 out here, so that's greater than 1, so that's going to be a vertical stretch by 4. So that's going to be a vertical stretch by 4. And then we have this x plus 4. So just like in the last one, that plus inside means it's going to be a horizontal shift left. In this case, 4, since it's a plus 4. And then that plus 4 outside, this is what we typically think. So it will be a vertical shift up 4. So those are the things that are going to happen in this graph. And then again, we can go ahead and use Desmos for this. So if I were to type this in, again, I should be able to look, -4, +4 should be our vertex based off of what we know about vertex form. If we look at the notation from our notes, so -4, and then in parentheses we have x plus 4, and we can close that, and then we have plus 4. So we can definitely see that -4, 4 is our vertex that I can click on. So now I want to be able to use that table. So make a table. -4 is our middle number in the table, since that's our x value for our vertex. And if I were to try to graph these, I can't graph 0, -60. That's not on that graph, so we definitely need to change these. So -4, and then we have -3 and -2. And it doesn't matter which side you go on. You just need to make sure you continue on both sides. And then we have -6, so we can definitely see that symmetry, -4, 4, 0, 0, -12, 12, and those are definitely points that I can put on our graph. So we have -6, -12. And this graph is going by 2s, so -5, 0, so in the middle of that. And then we have -4, 4. And we have -3, 0, so in the middle of -2 and -4. And then we have -2, -12. So if we go ahead and draw our parabola, it should look something like that. All right, last one from the first page. So now this is an intercept form. So we want to graph, so we can use Desmos. But if it's an intercept form, I technically could do zero product property to at least get our x-intercepts. So x equals 2. So that would be a point on our graph for sure. And then if I have x plus 2 equals 0, -2, -2, x equals -2. So we know those 2 points, but that's not enough. Our vertex would have to go in the middle, so it's going to be 0 something, which we could plug in and figure out what that is. But again, we have Desmos at our resource, our availability for us to be able to use. So if I were to go ahead and type this in, we have y equals, and then in parentheses, x minus 2. And then in parentheses, x plus 2. And if we graph, we can click on our vertex. We have 0, -4. So when I go to make my table, that's nice because 0 is already that middle number. So I can use these values here, -2, 0, which was our x-intercept that we calculated, right? It was ZPP, -1, -3, 0, -4, 1, -3, and 2, 0. So it already gives me that symmetrical effect. So -1, -3. We have 0, -4, and we have 1, -3, so we can go ahead and graph that, and it should look something like that. And then I also said to state our domain and range, so my domain is all reals. My range, very bottom, is going to be -4. It's everything above -4, so we know to state that as y is greater than or equal to -4. So there's the third page. Almost done. Last page, I've got some other ones that I want to look at as well. Almost done. Almost on spring break. All right, so our directions, find the zeros of each function. So that's already in intercept form, that's already in factored form, so we're just going to use zero product property like last chapter. So make sure we're showing our work for this. So this one's easy, just add 4, and n is equal to 4. This one, I guess, is an extra step. Add 1, 8n is equal to a positive 1. Divide by 8, so n is equal to 1/8. So if I were to graph this, we don't have to. Our parabola would cross at 1/8, and our parabola would also cross at 4. So that's our zeros. So in this case, v squared minus 8v. We got to figure out how to factor this to get it into factored form. So first thing we always look for is a GCF, which that has. Both of them have a v. So I can factor out a v. If I take a v out of v squared, I have a v remaining. If I take a v out of negative 8v, I have minus 8. So now that's in our factored form. So those two pieces there need set equal to 0. So v equals 0. That's one of my zeros. So again, on a graph, it would cross the x-axis at 0. And then I also need to set this equal to 0, add 8. So v is equal to 8. So my two zeros would be that. So again, those are just what we found in last chapter as well. So then 21 is equal to 0, so I'm good. I don't have a greatest common factor in all of those things, so we just have to factor. So we can use our diamond. My a value is just 1, so I don't have to make a box. But a times c is negative 32, so I need things that multiply to negative 32, and then I need things that are going to add to a 4. So we can think about all the things that multiply to negative 32, negative 32 and 1, but that can't give me 4, negative 2 and 16, but that can't give me 4, and then I have 3 doesn't go into it, 4 and 32, so that can definitely give us a 4. So we need to figure out which one's positive and which one is negative. So multiply to negative, one of these need to be negative, but it needs to add to a positive 4, so we need the negative 4 there, right? So now I can write this into factored form. So b plus 8 and b minus 4 is equal to 0. And then I have the capability of using zero product properties. So b plus 8 is equal to 0, b minus 4 is equal to 0, and then minus 8 minus 8, b is equal to negative 8. So there's one of my zeros on my graph. Plus 4, b is equal to a positive 4. So there's another 0 on our graph. So b equals negative 8 and b equals 4. If I were to put this in Desmos, we would see it would cross the x-axis at those. Alright, so 24, just a couple more. So 24, a value is not 1, so I'm going to have to do a box if I factor, but I first want to look for greatest common factors. So 6, 3, and 2, 23's got nothing. 20 has 2, but it doesn't have 3, so we don't have any greatest common factors. So if we go ahead and make our diamond, we need a times c, so we got a little bit bigger numbers here, so I have 120, and then our b value is 23, so I need things that multiply to 120. So I'm going to list out some things, 120 and 1, that doesn't give me 23, so 60 and 2, that also doesn't give me 23, so 3 goes into 120 40 times, that also doesn't give us 23, so 4 also goes into that 30 times, so we're getting closer, but that still doesn't work, and then I have 5, so that is 120 divided by 5 is going to give us 24. So 24 and 5, which is close, but it doesn't give me 23, so I can't use that. And then if we try 6, 120 divided by 6 is going to give us 20. So I have 20 and 6, but that still doesn't give me 23, so I don't have that. 7 doesn't go into there, at least I'm pretty certain it doesn't. So 120 divided by 7, we can try that in our calculator, and that doesn't work. So if we try 8, so 120 divided by 8 is 15. So I have 15 and 8, and finally that can give us the 23 that I need. So I know to fill this in, I have 15 and 8, both of those are positive, but I still have to do a box here because my a value is 6. So we have to recall from last chapter how to set that up. So top left is my value here, so I have 6k squared. Our bottom right is our 20, so I have 20. And then I'm filling these in whichever way, so 15k and 8k. So now we need to find the GCF of this row and put it out in front. So my GCF of 6k squared and 15k is 3k, and then we're playing the multiplying game. So 3k times what would give me 6k, and that would be 2k, and 3k times what would give me 15k, and that would be 5, and 2k times what would give me 8k, that's a ugly looking k, and that would be 4. And then I can double check, is 4 times 5 20? And it is. So we can factor into 3k plus 4 and 2k plus 5, but we haven't found the zeros yet. I would then need to use zero product property for each of these things. So 3k plus 4 equals 0, 2k plus 5 equals 0, minus 4 minus 4, 3k equals negative 4, and then divide by 3, k is equal to a negative 4/3. So that's one of my zeros, and then over here just solving as well, so minus 5, 2k equals negative 5 divided by 2, k equals negative 5/2. So those would be my two zeros for 24. So we're also going to have to do a box for this one because my a value is 3. Alright, last one that we're going to do together, 26. We want to write it in standard form, so we're working backwards of what we just did up above. So we found our x-intercepts in this case to be 4 and 1/8. Well, how I get it to be 4 is that n minus 4, right? It's a little bit more challenging if it's not just a nice, neat number, which is what I'm giving you. Or in this case, if I have an 8, I would need v minus 8. So we're doing that same thing. So if I wanted to get a negative 3, I would have to have x plus 3, right? I would set that equal to 0 minus 3 gives me that negative 3. And to get that positive 2, I would need to have x minus 2. So now that's an intercept form, but I need to be able to get it in standard form. So you can distribute, or you can make your box. So we'll do that. So I have x and a 3, and I have x and a negative 2. So if I fill in our box, x times x is going to go in here, so x squared. X times a negative 2 is negative 2x. X times 3 is going to give us 3x, and 3 times negative 2 is negative 6. So I got some like terms there. 3 and negative 2x are going to give me a positive x. So I have x squared plus x minus 6. So that would be in standard form. Okay, so then 27, 28, 29, and 30, you want to put on some graph paper. That's like what we did and you submitted on Google Forms for homework 48, I believe it was. So graph the points, figure out, is it linear, so is it in a straight line? Is it going to be exponential, so it's that curve? So this is linear, this is exponential, or is it going to be quadratic, and that's our whole parabola. So we're graphing those points and figuring out what shape that's going to be, linear, exponential, or quadratic. All right, hopefully this was helpful. Again, you can skip around as much as you want to. Enjoy your spring break. Hopefully you don't have to worry about too much stuff, too many things over spring break as you have all your work done. Suppose if you don't have all your work done, you need to go back and submit homework 47 and homework 48. Late is better than nothing at all. And we will see you guys in a week or so. So enjoy your time off and stay safe. All right, bye. So make sure you also upload this review so you can scan it as a PDF if you have that capability, or you can take photos and add that on Google Classroom there too.